All right, so section 4.3 is all about graphing rational functions. And to do that, we're going to go through this process. I'm going to briefly describe some things, and then we're just going to get right into it because I think that's probably the easiest way is just to relate all this to an example. So the process for graphing rational functions starts off with factoring the numerator and the denominator completely. And this will help us find the domain. So again, we're looking for restrictions in the denominator. Okay, and then we are going to look for y-intercepts, and remember that happens when x equals 0. If you plug in 0, you'll find the x-intercepts. If 0 is not in your domain, so if you have a factor of 0 on the denominator, there will be no y-intercepts. Then you're going to look at the factors of the numerator. Okay, anything that makes the numerator equal 0 will be an x-intercept. We're also going to look at the behavior of the graph near x-intercepts, and actually we're going to do this on a sign chart. And then if our function is in lowest terms, and we're going to look at examples when it's not, and we'll put it that way, we're going to look for the zeros in the denominator, and this is going to tell us our vertical asymptotes. Then we'll identify any horizontal or oblique asymptotes, and remember we call these slant asymptotes, or SA, and we're going to plot those. And then this is what I was talking about with the sign chart. We're going to, on our number line, our sign chart, we're going to put anything that is x related. So we're going to put in vertical asymptotes, x-intercepts, anything that is going to happen around the x-axis. And then we're just going to connect all the information and look at a graph. So in example 1, we have a graph of a rational function, and first thing we do is factor. So the numerator is already factored, so I'm just going to keep that the same. But the denominator, I can factor this into x plus 2 and x minus 2. So if I set these equal to 0, I know that my domain cannot include the values of x that are negative 2, and x cannot equal positive 2. All right, so that would give us a 0 in our denominator, and that can't happen. And this is where our vertical asymptotes come in. We're going to have vertical lines through these values of x. So our vertical asymptote is going to be a vertical line at x equals negative 2 and a vertical line at x equals 2. So I'm just going to go ahead and put these on our graph. So here's a positive 2, or negative 2, and a positive 2, and my horizontal asymptote, vertical asymptotes go through these points. So I'm just going to put dotted lines here to represent our vertical asymptotes. Then I'm going to look for my x-intercepts. My x-intercepts happen when the numerator equals to 0. So I'm going to look at anything that I can put in for x that gives me a 0 on the numerator. So in this case, if x minus 1 equals 0, I know x is 1. So the point 1, 0 is an x-intercept. And I'm going to put that here. Now my y-intercept happens when x is 0. And if I plug in 0 into the function, I'm going to have 0 minus 1 is negative 1 over 0 plus 2 and 0 minus 2. So 0 plus 2 is 2 times negative 2. This is going to be negative 1/4, or negative 4 on the bottom. Two negatives make it positive, so my y-intercept is going to be the point over 0 up 1/4. So if this is 1, 1/4 would be about right here, and this would be a y-intercept. My horizontal or slant asymptotes come from comparing the numerator and the denominators, those highest exponents. So in my numerator, I have a degree of 1. So my denominator has a degree of 2. So when my denominator is greater than my numerator, and 2 is greater than 1, that means I am going to have a horizontal asymptote at y equals 0. So that would be the x-axis, so I'm going to have a horizontal asymptote here. Now what I need to do is we're going to make a sign chart, and on our sign chart we're going to put in all of the things that are important for x. So I have a vertical asymptote at -2. I have an x-intercept at 1 and another vertical asymptote at 2. Okay. Also, yeah, that's perfect. So now I'm going to look at what happens as I approach -2. So I'm going to pick a number this side of -2 to the left of -2, like -3. I'm just going to slide this up here. So if x is -3, let's see what happens. Is the graph positive or negative? And I do that by plugging this into the 3 factors that I have here. So -3 minus 1 is -4, and remember, I'm just concerned with the sign here. -3 plus 2 is -1, so that's negative, and -3 minus 2 is also negative. So at x equals -3, my graph is going to be negative. All right, so anywhere to the left of -2 in this area right down here, I'm going to have a negative part of my graph, or my graph will be negative below the x-axis. So this is going to look kind of like this. It's going to approach the asymptotes. So it's going to approach the x-asymptote as it, or the vertical asymptote as it gets closer to -2. And as we go farther to the left, it's going to approach the x-axis. All right, so this is one area of my graph. Then I'm going to look at a number between -2 and 1. And I know that 1/4 is positive. Okay, so if I choose another number like -1, let's give me a better idea of what it's looking like in between the 2 vertical asymptotes. So between -2 and the x-intercept at 1, I'm going to choose a -1. If I plug in -1 here, -1, that would give me -2, which is negative. -1 plus 2 is positive, and -1 minus 2 is negative. Now I have 2 negatives here, which is an even number of negatives. So between -2 and +1, all of these values are going to be positive. So that means as I approach -2, I'm going to come down here and I'm going to kind of turn, and I'm going to hit my x-intercept at 1. So then I need to decide what's happening between my x-intercept at 1 and my my vertical asymptote at 2. So I need a number between 1 and 2. So let's try x equals 1/2. Oops, let's make that 3/2 because that's between 1 and 2. So let's try 3/2. So if I plug in 3/2 minus 1, that would be 1/2. That's positive. And on the denominator, I have 3/2 plus 2, that's positive. And 3/2 minus 2 is -1/2, so that's negative. So that tells me in this area where 3/2 is, I'm going to have a negative value. So it's going to cross through this x-intercept, which also, by the way, is on my horizontal asymptote. And just to remind you that a graph can pass through a horizontal asymptote, but never a vertical asymptote. So this area is going to come down and approach our vertical asymptote here at 2. So this was negative in this area. So then I need to determine what is happening to the right of this vertical asymptote. So if I pick a number over here like x equals 3, and I plug in 3 into my function, 3 minus 1 is 2, so that gives me a positive value. 3 plus 2 is positive, and 3 minus 2 is positive. So to the right of 2, I'm going to have all positive values. So that's going to look like this. Because all my values have to be positive to the right of 2, it's going to approach our vertical asymptote, and it's going to approach our horizontal asymptote, because that's going to give us the dividing line between positive and negative. So all of these values have to be positive. All right, so this is kind of what our graph looks like here. So let's do another one. And these kind of at times can look a little crazy. So this next one, we have a function. If I factor the numerator, I have the difference of squares, so x plus 1 and x minus 1, and I'm left with an x on the bottom. So because I have just a single x on the bottom, I know that x cannot equal 0, which tells me I have a vertical asymptote at the line x equals 0, which is our y-axis. So here's my vertical asymptote. So my x-intercepts come from my factors on the numerator equal to 0. So if x plus 1 equals 0, then x is -1, and the point -1, 0 is on my graph. And if x minus 1 equals 0, x equals 1, so the line, or the point, 1, 0, is on my graph. So I'm going to draw that in here. So here's 1, here's -1. These are x-intercepts. Now for my y-intercept, I'm looking what happens when x is 0. And because x is 0 is not part of my domain, I'm not going to have any y-intercepts. No y-intercepts, because x cannot equal 0. That means I'm not going to cross this vertical line, which is the y-axis, so I'm not going to have any point that crosses or gives me a y-intercept. So then I have horizontal and slant asymptotes. And again, I'm going to compare my numerators and the denominators. So the numerator degree is 2, which is greater than the denominator degree, which is 1. And it's greater by 1, which tells me I'm going to have a slant asymptote. And to find the equation of the line for that slant asymptote, remember I'm going to do some division. I'm going to do some long division here. So I'm going to divide x into x squared plus 0x plus 1. And I know x times x is x squared, so this is going to be x squared. Subtract, bring down the 0x, so that's nothing. And my remainder is going to be plus 1. Now our remainder doesn't have anything to do with our slant asymptote. We're just looking at the number we get when we divide into. We don't care what's left over. So in this case, my slant asymptote is going to happen at the line y equals x. All right, so this means my slope is 1 and my y-intercept is 0. So this is 1 right here. It's just going to be the line y equals x, which is the diagonal line here. Okay, so now we need to look at what is happening in our areas around our x-intercepts and anything that's actually happening with x. So this is where I'm going to create my number line. And on my number line, I'm going to put a -1 here because I have an x-intercept there. I have a vertical asymptote at 0 and a x-intercept at 1. So I need to look at what's happening to the left of my x-intercept. So let's pick a number like x is -2. So if I pick x is -2 and I plug in -2 into the 3 factors I have here, -2 plus 1, that's -1. -2 minus 1 is negative over a negative. So this is negative. So left of -1 is negative. So that's going to look like this. It's going to come from approaching my slant asymptote, and then it's going to hit my x-intercept at 1. Now let's look to see what happens between -1 and 0. In that case, I'll pick x is -1/2. When I plug in -1/2, I get -1/2 plus 1 is +1/2. That's positive. Negative minus a number is going to stay negative. And a -1/2 on the bottom is negative. So this gives me 2 numbers that are negative, so I get a positive here. So above my, to the right of my x-intercept at -1, I'm going to keep going up and I'm going to approach my vertical asymptote. Now I need to look to see what's happening to the right of 0, like in this area right in here. So to the right of 0, I'll pick a number like +1/2. So if x is +1/2, I put this in here, I have a positive. 1/2 minus 1 is a negative, so I have a positive and a negative and a positive. So this, with 1 negative, is negative. So between 0 and 1, these values are negative, but they're not going to cross my horizontal asymptote. So it's going to approach my x-intercept at 1. And to the right of 1, let's say x equals 2. Plug in 2 plus 1 is +3. +2 minus 1 is +1, so both those numbers on top are positive, and a positive here on bottom gives me a positive number. So to the right of 1 are going to be all positive numbers, so it's going to approach our slant asymptote. So that's what this graph looks like. In example 3, I need to factor my numerator and denominator. I have a common factor of a 3 and an x. So this is 3x times x minus 1. On the denominator, I'm factoring a quadratic trinomial, so I'm looking for numbers that multiply to be 12 and subtract to be 1. So that would be 4 and 3. And because I multiply to be a negative, one's positive, one's negative, and the bigger number has to be positive. So x plus 4, x minus 3. That gives me a domain of all values for x except for where the denominator is 0. So x cannot be negative 4 and x cannot be 3. And that's where my vertical asymptotes are. So I have vertical lines at x equals negative 4 and x equals 3. So if I put those in, x is negative 4, that's this one. X equals 3 is right here. And if I look for x-intercepts, that's anywhere the factors on the top equal 0. So I can take this factor here of 3x and say 3x equals 0 and x equals 0. So the point 0, 0 is an x-intercept. Then I can take x minus 1 equals 0. So x equals 1 and the point 1, 0 is an x-intercept. So that's right here. Finding the y-intercept, and I tried to stress this earlier in the last couple sections. If you have an x-intercept of 0, it's also intersecting the y-intercept at 0. So the point 0, 0 is also a y-intercept. Now for horizontal and slant asymptotes. Comparing our degrees, our degree in the numerator and the degree in the denominator are equal. They're both squares. So because my exponents in the denominator are equal, we're going to look for coefficients. Okay, so the coefficient of the x squared in the numerator is 3, and the coefficient of x squared in the denominator is 1. I'm going to have a horizontal asymptote at the line y equals 3. Horizontal line at y equals 3. So 1, 2, 3, and a horizontal line there looks like this. So I've got a bunch of information here, and let's look at what's happening. So if I draw a number line, I have an x vertical asymptote at x equals negative 4. I have, let's see, an x-intercept at 0. I have an x-intercept at 1. And I have a vertical asymptote at 3. So I need to check values in all of these sections. So if I look at a number to the left of negative 4, so x is negative 5, and I'm going to go way up here to do this. If x is negative 5, and I plug in my equation, negative 5 times 3, that's negative 15, and negative 5 minus 1 is a negative. Negative 5 plus 4 is a negative, and negative 5 minus 3 is a negative. So I have 4 negatives here. So in this area, to the left of negative 5, I'm going to have positive values. And it's going to be positive in this section here, to the left of negative 4. So the graph is going to look like this. To the left of negative 4, it's going to keep approaching our horizontal asymptote at y equals 3, and it's approaching our vertical asymptote at y equals negative 4. So then between negative 4 and 0, I need to determine what's happening here. So where is my graph there? I'm going to pick a number between negative 4 and 0, like 2, negative 2. So if x is negative 2, plug it into the function. Negative 2 times 3 is negative 6. That's negative. Negative 2 minus 1 is negative. Negative 2 plus 4, that's positive. And negative 2 minus 3 is negative. So because I have an odd number of negatives, in this area, my y values are going to be all negative. All right, so what that means is to the left of negative 4, my y values are going to be negative, and it's going to approach my x and y intercept at the origin. So now I need to know what's happening here. Is it going to go through this and then turn around or keep going up, or is it going to turn and continue to go down? So in this area between 0 and 1, I need to find out what's happening. So between 0 and 1, I have an x value of 1/2. If I plug in 1/2 here, 3 times 1/2, that's positive. 1/2 minus 1 is negative 1/2. 1/2 plus 4 is positive, and 1/2 minus 3 is negative. 2 negatives is an even number, so I have a positive value between 0 and 1. All right, so this is kind of going to come up above the x-axis and turn around and hit 1. So now between 1 and 3, let's look at a number like 2. If x is 2, and I plug in the equation, 2 times 3 is 6, that's positive. 2 minus 1 is 1, that's positive. 2 plus 4 is positive, and 2 minus 3 is negative. So to the right of 2, until we get to our vertical asymptote, is going to be negative. So this is going to kind of come down and approach my vertical asymptote. Then to the right of 3, we have one more area we need to check. I'll pick a number like 4, and I'm running out of room here. If x is 4, is it positive or negative? So I will plug in 4. 4 times 3, that's positive. 4 minus 1 is positive. 4 plus 4 is positive, and 4 minus 3 is positive. So at x equals 4, and anything bigger than that is positive. And it's positive way up here. So it's going to turn, approach the vertical asymptote, come down, and then approach the horizontal asymptote. All right, so that was another crazy graph. All right, so we got another one here. This one is really crazy. We have a numerator that has the difference of cubes, and we did some reviewing with our difference of cubes in section 4.1, and to factor that, we're going to have the numbers without the cube, so x plus 1, and then I'm going to have a trinomial, so that's going to be the number squared, which is x squared, and then I'm going to take 1 times x and change the sign, and then square the last number, so that's 1. On my denominator, I have a common factor of an x, so I'll pull out an x, and then I have x plus 2. My domain is anything that makes the denominator 0, so I know x cannot equal 0, and x cannot equal negative 2. And that gives me my vertical lines at x equals 0 and x equals negative 2. Those are my vertical asymptotes. So a vertical asymptote at 0 is here. and a vertical asymptote at -2 is here. Now I'm looking for my x-intercepts, and my x-intercepts will be anything that makes the factors on the numerator equal to 0. So I know x minus 1 equals 0, so my x-intercept is going to be at -1, and the point -1, 0 will be on my graph. And this right here is not factorable. So if I were to solve for x using the quadratic formula, I'm going to get an imaginary number, and that's not part of our domain, which is all real numbers, so I'm not going to get any x-intercepts out of this. My y-intercepts, next step, my y-intercepts are going to come from what happens when x is 0. So if x is 0, if I look up here, that's not part of my domain. So if x cannot equal 0, I'm not going to have any y-intercepts. Okay, no y-intercepts. And again, if I have a vertical asymptote through my y-axis, I cannot cross that in my graph. You cannot cross vertical asymptotes, but you can cross slant and horizontal asymptotes. Speaking of horizontal and slant asymptotes, let's compare our numerator and denominator degrees. So my numerator is greater than my denominator. This is 3, this is 2, and it's greater than my denominator by 1, which means I'm going to have a slant asymptote. And to find the equation of my slanted line, I'm going to do some long division. So I'm going to take x squared plus 2x and divide that into x to the third plus 0x squared plus 0x plus 1. X squared times x would give me x to the third, and x times 2x is 2x squared. And I'll subtract, and 0 minus 2 is -2x squared. And I'll bring down my 0x and bring down my 1. So x squared minus 2 is -2x squared. So see the importance here of being able to do long division. So -2 times 2x is -2x squared. So -2 times x squared is -2x squared. -2 times 2x is -4x. And when I subtract, I get 0 minus -4x is +4x. And because x squared won't go into 4x, this is my remainder, which doesn't matter. So my horizontal asymptote happens at y equals x minus 2. That's the line of my horizontal asymptote. So if I draw that line in here, here's -2, and I have an up 1 over 1 slope. My horizontal or slant asymptote is going to happen here. All right, so vertical asymptote, slant asymptote. So now I get to determine what is happening in these sections of the graph. So I need a number line. I'll do that up here. And on my number line, I need a -2. I need a -1 for x-intercept, vertical asymptote at 0, and I think that's it. anything that's happening at x. And I can look at 2 as well, since this slant asymptote is crossing at 2. And I'm going to actually use some space down here. I'll do this in class so that we can have a little bit more space. But if I try and cram everything in, I'm going to make a mistake. So let's not do that. Let's look at a number less than -2. So if x is -3, what happens? I'm going to go back to my function. At -3 plus 1 is a negative. Then -3 squared is +9 minus -3, that's 12, that's 13, that's positive. On the denominator, I have a negative for -3, and -3 plus 2 is negative. So at -3, my graph is going to be negative. So to assure that all of these values are negative, this is going to be kind of extending these here. My graph is going to approach my slant asymptote and kind of turn down this way. Okay, all of these values have to be negative. Now let's look at what happens between -2 and -1. All right, so I need a number between -2 and -1, like -1.5, which is the same as -3/2. So let's test that number. X is -3/2. So going back here, maybe I can zoom out a little bit. -3/2 plus 1 would be a -1/2. -3/2 squared is +9/4, minus 1, which would be 4/4, so that's +5/4, plus 1 whole, so that number is positive. Then I have -3/2 as a single factor, so that's negative. And -3/2 plus 2 is a positive number. So 2 negatives here make it positive. So between -2, whoops, let me see here. I think I made a mistake here. -3/2 plus 2 is negative. Should be negative. -3/2 plus 1 is negative, positive, negative, negative. So 3 negatives, I'm sorry, I'm losing my train of thought here, is a negative. So here, if this is negative and I'm approaching my x-intercept of 1, okay, I can cross my slant asymptote, so this is going to continue to go down. I have a vertical asymptote between these 2 branches of my graph, and now I'm going to get up to -1. Now, between -1 and 0, I have an x value of -1/2. So now if I plug in -1/2 plus 1, that gives me a positive number. -1/2 squared is 1/4 minus a -1/2, that'd be 3/4 plus 1, that's a positive number. -1/2, that's negative on the bottom. And -1/2 plus 2 is positive. So this is going to also give me a negative number. Sorry about that, you couldn't see that. So -1/2. Top, I have both positive factors, a -1/2 for the x, and a -1/2 plus 2 is positive 1.5. So one negative number is negative. So at this x-intercept of -1, it's going to turn the corner and it's going to come down and approach our vertical asymptote, which is the y-axis. Ooh. Now I'm going to look at what happens to the right of 0. And to the right of 0, let's just pick a number like 1. So if x equals 1, I'm going to go back to my function. 1 plus 1 is 1, that's positive, and this is going to be positive. So positive, positive on top, 1 is positive, and positive on bottom. And anywhere I go bigger than 1, if I put in 4 here as an x value, 4 plus 1 is positive, this is positive, positive, positive. So anywhere to the right of 0 is going to be positive. And what that means is if I am approaching my vertical asymptote, these are positive numbers, and then I'm going to turn the corner, and I can't go below the x-axis because this is all positive, and I'm going to turn and go this way. So all of these values need to be positive as well. All right, so I think we're going to take a break and stop there, and we'll pick up with example 5 in class.